let f of x equal the square root of the quantity 5x squared plus 4x plus 5. So here we're taking a square root of something more than just a single term, which means we're going to have to use the chain rule because what we have, I could rewrite first off as 5x squared plus 4x plus 5 raised to the 1/2 power. And that's always a great idea to do because we don't have any separate rules for taking derivatives of roots themselves, but we do for powers that are rational, irrational, whatever. So we can use the power rule. Now, I have something that's a bit more complex than just an x here. So I have a function, and I'll call that function, say, u. So we'll say u of x is 5x squared plus 4x plus 5. So that defines an inner function. So the function f of x is really this function u to the 1/2 power. And what I am told by the chain rule is I can do the derivative of the outer function as I would normally. But then I have to multiply by the derivative of the inside function. So going back to my original problem here, so this is what's always happening behind the scenes. But in the end, how we work these problems through generally is we notice that there's a function raised to an exponent. So we bring the exponent down, leave the inside function alone, subtract 1 from the exponent, so that would give me a negative 1/2, but then multiply by the derivative of the inside part, which is the 5x squared plus 4x plus 5. So this gives me a derivative of 10x plus 4. And notice, this is the function u, and this is the function u prime. So we have the exact same thing that we stated right over here. So we might not be saying these steps, but we're absolutely doing those steps. Now, simplifying, there's really not much you can do. It's generally wise if you have a negative exponent to try and make that a positive exponent. And instead of writing something to the 1/2 power, changing that to back to a root. So we could write this as, and actually there's a common factor of 2 shared here, which we could cancel that out. So we could say, for instance, this would reduce to 5, this would reduce to 2, and cancel with the 1/2 there. So 10 divided by 2 is 5, 4 divided by 2 is 2. So that's something we could do. Effectively, we end up with 5x plus 4. That's the only thing left in the numerator. And the denominator, I have this root 5x squared plus 4x plus 5. And that's a perfectly fine answer, or the one prior to is perfectly fine as well, unless it's specified to write in the simplest form.